Okay, so we are talking about inscribed angles with the same or congruent intercepted arcs. And I already talked about this in the very first video. Let me make my circle a little bit bigger this time. Okay, so if I have this inscribed angle and this arc is 120 degrees, then I know that the inscribed angle is half of that, which means that's 60. This still has the same intercepted arc, because that's where the endpoints are. So that angle is also 60. Same intercepted arc. That is also 60. And I could do this all the way around. That's also 60. Okay? If they also have congruent arcs. Okay, so we're going to do this example. And I like this example because it is taking what you already know, like your past knowledge, and applying it and proving this. So we are going to draw an equilateral triangle. Okay, so we have an equilateral triangle inscribed in a circle. So then we got to figure out, okay, what all do we know about an equilateral triangle? Well, we know that all the angles equal 60, and we know that all the sides are congruent. So using what we just did, this angle right here is an inscribed angle. So if I follow it to its arc, that means this is going to be 120. So then following this piece, here's 60, following it to its intercepted arc, that's also going to be 120. And then finally, the last little arc is also going to be 120. There's a couple things that come out of this. So we still have the 120, the 120, and the 120, so those all equal 360. And because this angle and this angle are the same, they have congruent intercepted arcs. And then something that we're going to probably be leading into is that if this chord and this chord are the same, then these arcs are the same, which also happens in that particular problem.